Troubleshooting 101. Welcome back to Tech Train Solutions, the podcast where we dig deep into the tools and techniques and tips that keep the industrial world running. I'm Sean Quinn, and today we're tackling a topic every electrical technician, maintenance person, tech should face sooner or later: troubleshooting calmly and understanding electrical issues in the industrial setting, and sometimes just troubleshooting an operational problem. It could be a mechanical, operational, or strictly electrical. Well, that's where you decide. In my industry, where I came from, the electrician was a first line of defense. We went out, we figured out what it was. Whether you're working on a factory floor, a processing plant, or a large-scale facility, electrical problems can bring productions to a halt. When this happens, time is money. Sometimes you lose in thousands, 100,000s. Some will lose millions. So we're going to walk you through the most common issues and the best practices to get systems back online safely and effectively. Segment 1. Why are you troubleshooting? And why does it matter? With the rise of AI and other tools that are coming out that help you with troubleshooting, or preventive maintenance systems that help you determine what to do next, that is great. That is awesome. But sometimes in the middle of the night, in areas where technology does not work, or you just can't bring a laptop with you, sometimes we need to dig deep before we jump into the nuts and bolts in troubleshooting. Let's talk about troubleshooting, which is critical in industrial environment. Downtime, again, costs millions of dollars. A simple motor or control circuit issue can ripple through the whole process. You are the first line defense. You, the electrical technician. You're going to have to think, and you have to be on your toes. And sometimes you're going to have to be an operational or mechanical person at the same time. But it's not always about speed. It's about safety. You got to do it safely. Do not get hurt. You want to go to work and come home the same way you came. So follow the procedures and protocols. If you don't, it can lead to accidents, equipment damage, or even worse, electrical fire or death. In some cases, you'll miss something when you're going so fast, or you're just going through the motion. You're going to miss something crucial. You're going to miss a finding that you should have saw if you took your time. And sometimes you have to walk away. You have to walk away and come back. Go get a glass of water, get something quick to eat, and come back. Sometimes that has to happen. There's times I'm 18 hours troubleshooting, and the next morning I figured it out within half an hour because I got away from it, went home. Let's talk about the common electrical issues. Let's start with the big one, the big issue, motors. Motors are everywhere in industrial settings. The last segment I talked about that. When they fail, it's bad. One time I worked in a distribution center. We had miles and miles of conveyors. One motor failure stopped the production line. This production line made 40% of the product. 40%. It usually is due to an overload. It could be too much product on the line. Could be a bearing failure. Could be a gearbox. And sometimes the motor just goes bad. There's a life cycle to motors. If you go to Baldor's website, you'll see they'll give you a life expectancy of a motor. That's with if it's running at normal temperature. If it's hotter, expect the life expectancy to go down. Sometimes the insulation just breaks down and causes a major short. But the majority of the problems I saw was because of mechanical bindness or stiffness, a belt too tight, a jam happening, some kind of other mechanical situation that you didn't see. One incident. I was in another department. This is a finishing line, and we just finished a PVM. I'm there, preventive maintenance. I'm there for startup. We had this machine called the Widowmaker. This machine was so dangerous. Siemens drives. Only gave you a product code number when a failure happened. We kept having a drive fault, overload fault. This is one of the things we just keep switching drives out because we think they failed. Well, I didn't think it was the problem because I'm like, look, this got to be mechanical bindness stiffness. I went to talk to mechanic. Mechanic's like, everything's fine. No, I made sure it's good. I'm like, okay. I go back to the machine. I'm talking hours, right? Hours trying to figure out what is going on. I'm checking here. Oh my gosh. One little set screw that holds this cylinder together. One was causing the problem. Just one little that far out. That was causing me that fault. These old Siemens drives aren't helpful. Man, it took hours. I used different techniques, troubleshooting techniques. I've tried amping the motor. I've tried checking the torque. I even made sure the motor was good. I would put a motor on the floor and it would run, like just sitting on the floor, and it would run with no problem. I dove deep into that process. I looked into every nick and cranny of that machine, everywhere. I checked each roller. This is moving. This one wasn't. I'm like, oh, something's wrong. I would go over to another machine to compare, and I rotate it. I'm like, this moves. I decided to go underneath the machine. I see that set screen. I seen it. It's the last one I checked. Now, finally, I brought the mechanic out to fix it. He finally like, oh, I didn't see that. Well, I did. This one piece of equipment kept us down for 4 hours. This machine, this department made about, I would say, 20% of the product in the United States. We were down for 4 to 5 hours. So again, majority of your problems in the industry is either mechanical bindings or stiffness, or like I call fat finger and operations. Now, if a motor fails, there are certain checks that you can do. If it's an overload, check the machine. Look for anything possibly tight, parts loose, something. Make sure you turn things by hand if you can. Then check the insulation of the motor if everything looks out right. Use something called a megger. The first thing I would check is in the ohms setting. Check each lead. About 5 horsepower down, you always will get some kind of reading. 1 horsepower, 575 motor, get 29 ohms phase to phase. If they all check, you're good there. Then check the phase to ground. If everything checks, you're good. Try it again. But don't get a cheap meter. A cheap meter bit me in the butt. A cheap meter, because it didn't have the low impedance, the wire leads were next to another VFD running a variable speed drive. It was showing 1 million ohms. 1 million ohms. I'm like, what? Between phase to phase. I kept checking. But occasionally I would get 29 ohms. I'm like, what is going on? Not knowing the drive failed. I spent 2 days, and I did a lot of research, and it said sometimes a VFD can send a false signal to that line, giving you 1 million ohms. It killed me. So having the right meter is what you are to become a good troubleshooter. Again, a quick way, let's say you check face to face and everything's fine. You try to run again and you don't see a mechanical stiffness and it's just an overload. Well, next, check the insulation. How do I check the insulation? This is further deep dive. It's called megging the motor. Megging the motor sends 1 million volts. Well, some can be 1,000. Depends on the setting. If it's 575, I only do 1,000. It sends it. What you're looking for is 1 million ohms of resistance. That is the million you want to see in that. If you see 1 million ohms, you're good. If you see less than 1 million ohms, you got a problem. This is to phase to ground, phase to ground, phase to ground. Phase to phase, you should see 0 ohms because it's windings. They're all connected. You should see 0. Anything less, you might have a problem. If you do all that, if you see less than 1 million, you might have a problem. So everything checks out. You're looking fine. Then there you go. Check for your motor mechanical binding and stiffness. Always check that first. Now let's move on to servos. Servos are the higher end motor systems. They have encoders. There you got to get deeper in the rabbit hole. It is imperative to understand or at least read up on the symptoms that you're seeing versus what the manual's saying. You're seeing a possible cause. VFD servo drives are not easy to troubleshoot. They give you a message, but not extremely easy. Read the message, try to understand that, because sometimes that message is right. You just don't know what you're reading. Do your best research. Hopefully, if your plan has AI, great. Always, again, check for mechanical binding stiffness. I once had a servo acting up. It was weird. It would go, it was doing this, right? It was just doing this the whole time in stationary. I dug deep. I drove in there. Nothing looked out of place. I looked at all the systems. I decided it must be the motor. It's got to be the motor. The encoder must be failing, right? The encoder, even though if it fails, it fails. That little thing, the encoders don't fail like that. So I thought it was the encoder motor. So I replaced the servo motor. Guess what happened? Nothing. Same problem. Same problem was still there. Still was going back and forth, back and forth. I did my research. I dove deep. It's a company called Control Techniques. That's the company. I researched it. I went into the chat, and I found out, believe it or not, settings. Somehow my settings on the drive was changed. So I did something called auto-tune. Auto-tune's where you set, the drive will set and look at the motor, moving it, right? You have the motion auto-tune, and you have the stationary. That kind of problem, I had to do the motor, that motion one. So that means I had to take it off and put it on the floor and then do the auto-tune. So I would look around, check all the information, and once it did that, it grabbed it and put it on the drive, and I clicked save. Once I did that, it went away. It went away. I didn't do any changes to that windings, right? I did nothing to that. Somehow it just changed on its own. I don't know how. So I did that. It went away. But before that, I did all my checks. Like I told you, I checked the servo motor to make sure I had the ohmic value. I had something called an encoder tester. I plug it in there and it gives me a reading from 0 to 12. It said 12, good job. This took me 6 to 8 hours to troubleshoot. 6 to 8 hours, that machine was down. All because of an altitude. My first impression was I thought it was that, but I ignored it. I ignored my first thought because I'm like, it can't be that because I didn't touch it. That's my Achilles heel. If I didn't touch it, and I listen to sometimes operations, I listen and do that. Sometimes I don't look at the full picture. That's what you got to look at. So let's talk about segment 3, Diagnostic Tools. So what is the troubleshooting toolkit? At a minimum, a good meter, clamp meter, and installation tester. Another good basic toolkit is understanding the mechanical process, understanding belt tension, understanding how gearboxes work, lubrication, understanding that. You get the great understanding of mechanical processes. That would be a great toolkit in your knowledge. Now, we'll go more complicated tools, which it helped me very much, is a thermal camera. It's great for spotting hot spots. There are times where you use the thermal camera and you're like, why is that motor hot? Motor's steaming. And you decide to look into it. It's not the motor, it's the gearbox. There's times where I'm looking at it and most of the heat's coming from the gearbox. The gearbox over time loses oil or grease. Sometimes you just got to re-grease it. We re-grease it. That temperature went down to normal temperature. Bang, done, over. That's why it's great to have thermal imaging. Now, there's another tool I used. I used oscillation, oscilloscope. Man, they're good. Oscilloscope, learn how to use that. It helps you with harmonics. It determines if the voltage is fluctuating. It helped me get out of trouble. You can check to see if the phase in phase is good. It looks for spikes in amperage and torque, so sometimes drives don't have that. So it helps you see the torque and amperage. But you do realize you have to be trained on it. Take the time to train yourself in oscilloscope. There's one time it kicked me in the butt. We were putting a new safety system in. And we're spending all day. I put all the new guts in. I did all the work. It looked beautiful, beautiful work. So I'm in there. We're troubleshooting. We're the experiment. We decide to keep testing. We're ready to start. We hit start. We're able to run for a minute. We go offline. Hit start again. I won't do it. It goes right to a fault. We're like, what is going on? We were pulling our hair out. I had official engineers there from that company that was building that for us. They couldn't figure out. So I'm like, gosh, man, we need to do something here. So I'm like, what else can we do? Because it's got to be something with the safety system. New components. The old safety devices gave you a pretty big window of tripping. These new safety MSRs, master safety relays, they trip quickly. So what we had to do, we got an oscilloscope. We hooked it up. And oh my, it was such an easy find. The contactor was bouncing so quick we couldn't see it, but the MSR did. From that bouncing, it was less than, I would say, less than 5 milliseconds, but the MSR, master say, was 2 millisecond set point. Oh my gosh, we spent hours on that. And all it was a master safety relay, was the bouncing of the contactor. That is it. So how did we fix it? We didn't. The company went back and put a safety PLC in instead. That's how they fixed that. But I'm just telling you, that is a tool to use. Let's talk about segment 4, best practices. Collect all relevant information by multiple avenues. First, ask operations. The machine. Ask questions like, did the machine sound normal to you? Did this happen before? Did you notice anything happen? Second, this is very important, understanding the process of the machine. You don't have to be an expert, but the operators have them describe the operations from point to point. Understanding the process, even a little bit, will help you determine the potential cause. Look for abnormal temperatures, smells, like electrical smells, loose connections. There'll be times I'll be pulling and wire comes out. And again, saying this again, mechanical biasness and stiffness. I keep saying this because this was 70% of my problem in my 17 years. Determine if it's a circuit breaker or a fuse. If it is, you got a serious problem. Or if it's an overload. Overload, again, could be mechanical biasness or stiffness. Once in a while, you'll have a circuit control circuit problem that it failed. For instance, the machine I was on that I went to later on, all the E-stops were over 10 years old. And we kept having weird E-stop problems. I pull up the cabinet, I see the spring of the E-stop like this. And I look at newer E-stops, the springs are all the way out like this. That dead spring would cause, when it runs, vibrate and open. Control circuit, quick fix. That one I kind of understood. I looked at the spring, I knew exactly what the problem was. It was easy to see that. So that's what I'm saying. Sometimes you got to dig deep into the process. Now, this is very important. Gather all the resources, such as prints, operational manuals, HMI screens, and logbooks if they have it from the technician. If there is no logbook, start creating one, guys. Start creating one. Definitely after collecting information. It is time. Once you get all that done, you have to now define the problem. This is pretty quick. All the ones I talked about are quick. It could be done in minutes, seconds. There's times I walk up, I know exactly what the problem is. Then you define the problem. Defining the problem gives you a roadmap in the troubleshooting process. It lets you pinpoint and helps you follow a path. Your job is to navigate to that solution. Example could be that motor I was talking about is not moving. Product's not counting right. That could be a sensor not flagging right. Getting too many or too little products. Could be devices, motors, or anything else overheating. I had my safety systems reach 190 degrees. Occasionally they would fault out. I decided to cool it down. I lowered it down to 100. I had no issues. Now, when I first started working at my workplace, I kept going over this department all the time. All the time. And it's always the safety systems or control systems. I was pulling my hair out, going nuts. I kept looking. And then I kind of realized I'm dealing with something called 24 volts. 24 volts and a lot of dust. 24 volts and dust don't like each other. So enough 24 volts and dust, it would even close, it would not have contact because the 24 volts doesn't have enough oomph to get through the circuit. You're defining that problem. So you did that. Now you have to define that problem. It is now to try to identify most likely cause using all the information gathered and come up with that cause. You may not know exactly what the device does. You may not. There's times where I'm like, this is the problem, but I don't know what it does. And if you're suspecting it, which I've done that, and I've ignored it and ended up being that problem, there's two ways to figure this out, what it does. First, There was times in my days where, again, I thought it was that device, and it was. I dug deep. I went back to my computer, did a lot of research. I went to the website of that company, figured out what the purpose of, and I left the floor researching like crazy, and I finally understood how it worked. Understanding how it worked gave me a great path, because I was able to either tweak the device to get it back up and running, because sometimes that happens, or somehow a part of the wire failed. I just replace it. It was back up and running, or I just need to change it. And sometimes it's obsolete. I don't have it, so the machine's down until we get it. It is what it is. What I'm trying to tell you, why I'm telling you to do this process, is I don't want you to be known as a part changer. A part changer is not a troubleshooter. He's very expensive. You don't want to be a part changer. A part changer in industry, you continue being that part changer and not a good troubleshooter, you're going to probably get fired, or you're going to get laughed at. So stop being a part changer. Get down dirty and do some troubleshooting. They got AI coming. Maybe they'll help you out. So once you figure out the problem, you got to develop an action plan. Test your potential solutions. Can it run without it? So can you plan to work? Is there a replacement part available? Sometimes you don't have that. What is the replacement time? Sometimes it takes 12 hours, 14 hours, 20, doesn't know. Is it truly mechanical work, electrical work, or maybe it's just operational retraining? Once you determine and gathered all the proper traits for support, now it's time to work. It is time. First, though, you got to make the job safe. The question you should ask is, you want to eliminate all harmful energy. What can I do to keep myself safe? Start working by locking, tagging out, and verifying it runs by hitting start button. So you did that. Then you apply all the chosen solutions. Evaluate the outcome. There's times where you thought you fixed it. It happened many times. I thought I fixed it, right? I go back to my room. I'm working third shift. I go back to my room. I don't sleep until Thursday back in the day. So Sunday to Thursday, no sleeping. So I go back to the room, just do a little prayer, closing my eyes. And then I get called 5 minutes later, problem came back. I didn't fix it. So that's why you have to stay there and babysit until it fails again. Look at for certain intervals of that. That's what you got to do. Don't leave it. Here's the next part that no one does. Document the entire troubleshooting process in what you did. At a minimum, at least do it for you so you can get yourself out of trouble again. Good. So it's easy. Look for a SharePoint to fill it in. Look for a filing cabinet, maybe a logbook, but document extreme details. And if the problem happens a lot, a nice size label. I used to label all my major problems and how to fix it. It got me out of trouble multiple times because they had to call me when I was home on the weekends. They fixed it. When possible, though, this is important. When possible, share with multiple assets. Let everybody else know the problem and the solution. Maybe they'll share knowledge with you for future reference with the problem solution, so you can fix things that they know, but you don't. I was that guy. When I became the trainer, everybody came to me for a problem, and I knew who fixed it and got them connected. That's what I did. And I made logbooks. I tried my best. But here's the future. Future's coming. AI. But if you don't have AI, at a minimum, you can do a video of you fixing it and then maybe put a QR code on the product or the machine. You scan the QR code, video comes up of how to fix that problem. This is the future. Let's talk about segment 5, real world scenarios. I was working on a machine the size of a small townhome. The machine had multiple servos, drives, encoders, sensing devices, including analog, digital. I went through the machine. I was working to try to find the problem. I go to the operator, ask what's wrong. He states about 20 minutes in, the HMI shows a fault code of 61. 61 in control techniques indicates mechanical bias, stiffness, or loose cable. I dug deep. I had our leadership say they checked all the mechanical bias and stiffness. There was nothing there. Everything is perfect. So it's got to be the servo, right? So I checked the motor to make sure I checked each lead, got a good ohmic value. I checked it in encoder with my encoder and tester. I put it on the floor, did an auto tune. Everything was fine. It ran great on the floor. I put it back in the system. I had him run it. 20 minutes later, happened again. I checked the motor again. Everything was fine. I made sure the encoder was again. I checked that. I checked the drive, make sure the drive's getting all the information. I did all my checks. I put the drives, I got hooked up to the drive, and I verified torque and amperage. And I would always get a spike of amperage and torque, right? Major spike, like for a little bit, and then it would fault out. It would run good, and I'll spike. And I'm like, oh, what's going on? So I thought it was the motor. I thought maybe the motor has a bad bearing. So I changed it out. I changed it out. 20 minutes later, the new motor failed. I'm not going to give up. So I went in the comfort booth with the operational team. It's third shift. I'm tired as heck, right? I'm not sleeping. And I'm sitting there kind of relaxing, BSing with the team. I'm like, I don't know what to do next. I'm confused. Man. And all of a sudden, we're getting relaxed. The operational team level, leadership, we're talking and go, this morning, I do realize the day work maintenance worked on that system. Like, oh, really? They worked on that today? Oh, yeah. They worked on it. It worked for about an hour or two, and then it started having problems. Like, and you said you checked for mechanical binding stiffness? Yeah, I checked everything I know. Do realize operational people, not all, aren't trained on belt tension. They think the tighter the better. Well, wrong. Tighter is not better in some cases. So what do? I got two machines. I shut down the other machine. I go inside. I check all the belts. The belt in question was not tight. It's kind of belt that had the legs in there, feet in there. It grabs. It's not meant to be tight. It's meant to be a certain torque, but not tight. I'm like, really? I'm talking 4 or 5 hours troubleshooting this. It took 1 minute. Again, I told you to get away from the system, sit down, and relax, and the problem will come to you. I get them to loosen the belt. Guess what happened? It ran. It ran all night. So again, mechanical, stiffness, and binding. So the question is, do you want to be a part changer or a real troubleshooter? Take the time. Learn your equipment. Be able to research and have a flexible mind. Here's another example I did too. Sometimes, I don't know why people don't do this, but you already have a problem with the machine. It's having major issues. I will purposely cause a sensor. I'll remove it and see what it does. Mark it. Write it down what it does. I'll put it back in if I thought it was that problem. If I think it's another problem, I'll remove it out of the system. See what it does. Mark it. It's not the problem. That's another way I troubleshoot, by causing an issue. Now, people get mad at me and stuff, but I'm letting you know, make sure it can't destroy it, but let you know, from doing that, I go from 4 to 5 hour troubleshooting to a half an hour, maybe less, because I'm finding out what these devices do in the process. There's times where I'll go to machine operators disappeared. I have to figure this out on my own. So I do that. I'll purposely cause failures and write down what they do and put it in my logbook. That's times you have to do that. If the machine's already down, why not? Or the machine's not running right and the operator's frustrated. He's not going to run it because he doesn't have nothing to do with it. Why not? As long as you know how not to destroy it. So let's wrap up. So to recap, common issues include motor failures, mechanical binding and stiffness, control circuit problems like bad E-stop, springs, modules failing. It could also be a safety system not working right. Contactors double tapping. Problems with power. That's another thing I didn't talk about. Sometimes the power could be an issue. You need the right voltage, plus or minus 10%. Whatever it wants, it should get plus or minus 10%. It could be a ground fault that you're not seeing. It runs. I had a motor run, and occasionally it would stop. And then I'm checking the motor. I'm not seeing nothing. I rotate it, and I found a bad spot. It goes right to ground. It wouldn't see it all the time. I would keep rotating the motor, right? And I'm like, oh, I see it. Went to ground. So ground faults happen. Remember, use the right tool. Follow a systematic approach. I am not that person. I'm not like that. But when it comes to electrical, industrial training, and all that, I am like that. My mindset changes. Never skip safety. That's another thing. Never do that. Now, if you want to go deeper or you want some training, which I'll provide at Tech Train Solutions, I'm here for you. For a limited time only, I'm offering free training after 3 p.m., except for Saturdays and Sundays. I can offer anytime. Or stay tuned to the next episode. We'll dig deep into the troubleshooting by learning how to do advanced PLC training knowledge. So thank you for listening to Tech Train Solutions. If you found this useful or helpful, share it with your team. Subscribe for more tips. Until next time, stay safe, stay sharp. There's a golden rule. Systematic approach. Stay shape. Oh, yeah. See ya.